when sharing the desktop, if that actually will appear in the archive. We will find out. Okay. Well, this class is a little different in that it is completely out of order with regard to the curriculum. It should appear, you should take this course at the beginning of your coursework. In speech and hearing, well, it's really more speech science. It actually should be a part of your anatomy and physiology class because you can't discuss speech science without discussing anatomy. So, because it's at the end of this class and because you have had anatomy, I'm not going to spend a lot of time on anatomy. I actually teach this class to the traditional students in, you might be, I don't know if the class is going to be easier, and the science part, if science is difficult for you, may be difficult. But what that does mean is that class time won't last long. So in the spring, I teach this class on 3 weekends, 3 Saturdays. And we go through the content 3 Saturday mornings. That's how quickly it goes because I'm not teaching you the anatomy and physiology. I'm just reviewing anatomy and physiology and focusing more on speech science. So the course outline that I sent out is the official course outline. However, we're going to reschedule. We're going to meet. I'm going to send you out a new one, and we're going to meet next week, and then after that, 2 more times. Now, it may be that we meet a good 2 hours, but I believe we can get through the. I'm sorry? But I believe we can get through the content in 4 meetings. I had my yearly eval, and I was told that I need to hold my class the entire time. And I said, okay, but I'm not going to hold you just to hold you. So, is there a particular, if you guys can send me, I'm just going to send out other than next Tuesday, I'm going to send out 2 more class meetings. And I'll probably pick a date in the last week in June and probably the middle of July. Is that I'm having, next week is fine. The week after next, I'm having surgery. I'm having a partial cornea transplant. And so I'll be on my back for 2 days. So we're for sure not meeting that week. So I will send out, I'll send out a new outline and revise the due dates based on the new schedule. Is everybody okay with that? Okay. Let's see. So I'm looking at June 27th and probably June 18th. I'll send out another one. by email. I'll keep the official one up in email just in case somebody peeks, although I doubt it. But I'll send those out, and then what we'll probably do after we cover acoustics, neurology, and respiration, the 27th will probably cover articulation of vowels, articulation of consonants, and prosody. And then the last class meeting will be feedback mechanisms, auditory cues, and speech perception. I think that's okay. So just hold on tight. If you got my email, I'm sorry. Go ahead. You're welcome. So we're going to, if you got my email, I postponed the test over acoustics until next weekend, and so you'll have 2 separate tests. And so I'll keep the tests separate, and so that they're weighted, and so that you won't have so much content. But I'll open the acoustics chapter test right after we meet next Tuesday, and then and then open up neurology and respiration next weekend. So it'll give us time to review this information next Tuesday. And neurology and respiration is not very long. I'll also go over the first lab with you. Let's take a look at the let's take a look at the Dropbox. Okay. Oh, so you're welcome to use your mic, but you have to cut the mic off when you're not using it. So the only thing that's due this weekend is the abstract. The abstract, I would like for you to pick articles from the content area. There's a list of articles. I would read through them, not through all of them, but I would kind of review them. And whatever speaks to you and you feel that it is the one that's easier for you to comprehend, that's the one I want you to pick out, because that's the one that'll be easier to summarize. Make sure you look at the rubric, because I'll be grading it based on the rubric, so I need you to write it based on the rubric. And please make sure that you try to put as much as possible in your own words. So that's the only thing that will be due this week. I'm going to postpone the lab, all of your labs except the last lab. We may actually do the last lab together during class. It's kind of weird. But all the labs will be done on through Pratt. Have you guys used Pratt before? And so there is an accompanying document that walks you through. I've also given you YouTube videos that will show you, oh no, okay. Let me ask you guys a question. When is your comprehensive exam? Oh, that's interesting. That's an interesting weekend. Okay. The whole point of this class is to introduce you to the instrumentation that you could possibly use as a speech pathologist. This class really illustrates that how you are different from a speech teacher or a speech assistant or a speech aide, a flipper. because it shows you how the decisions that you make with regard to speech production and speech perception is actually based on physics, it's actually based on science. And so there are several instruments that you use as a speech pathologist that you can measure to make objective measure of speech production. The CSL, the computer speech lab, is a common instrument that speech pathologists use, not probably in larger clinics or maybe in university clinics. But it would only make, this course needs to be legitimate in that you touch an actual instrument. Pratt is just a computer software application that can perform some of the analysis that the CSL does, but I would love for you guys to be able to touch the CSL. And the lab, and this is the lab that the traditional students do. Actually, it takes you about 5 minutes. What takes you a little bit longer is to do the analysis. It is an analysis of an abnormal prolonged ah, and number 10 gives you all of the analysis that Dr. Irwin said would be the most useful clinically. And so those are the ones that you're going to pick out of a full page of analysis that the MDVP report will give, and you just need to determine if the outcome, if the results are normal, and we're going to call normal within 1 standard deviation from the mean. So this is the issue. I know how crazy will you be? How ridiculous would it be for me to ask you to take a stab at this after you finish your comps? It will only take you 5 minutes. I will be there. I will walk through it with you. Is someone like flying right out that afternoon? Okay. Okay, that's fine. So if those of you who aren't taking it this summer, if you would email me and let me know, then I will find something else to substitute for this just for the purpose of a grade. But when you come in for your comps later, I still want you to put your hands on it. You're so funny, Brittany. Okay, so let's see. I proctored last time, so hopefully they won't have me proctoring. So in the morning, you take your objective portion and you break. Don't want to, I think that break, you need to actually break, maybe get some lunch, chill out, and then you come back and you take the subjective or the written case study part. And after you finish, just come to the audiology clinic. I will be there waiting on you. You guys sound like you've had a really hard time. I'm so sorry. Okay, so let me send out an email, or I'll put it on. And if you guys can, do you guys have a some type of social media application that you use to talk to each other? I know you are. Okay, so no lab. This, the only thing you have to do is your abstract. Lab project 1 will be due during that day of comms. And this is your P for your portfolio. This is what you're going to put in your portfolio for this class. Okay, hold on, let me go back. All right. So I'll go back in and revise the outline and the associated dates with the Dropbox. Okay, so let's quickly look at the course objectives. We're going to spend the time tonight on acoustics and kind of finish up next Tuesday. Just going to review anatomy and physiology. We're going to talk a lot about how the speech signal is produced and a little time about how it is perceived. And then you need to demonstrate that you have some competence in recording and analyzing sounds used for speech programs. So there are going to be a couple of labs that you'll use with Pratt where you're recording your own voice, analyzing your fundamental frequency. We're going to analyze voice onset time, and so that will meet that, and then you'll evaluate the measure. My teaching method is the same. Each of your exams are worth 13.5%. Your labs are 5 each. Again, lab 1 goes into your e-portfolio. You have a few discussions and your abstract. Let's take a peek at those discussions. Okay, the first one is not mandatory, but I would really like you to take a stab at it so you can think about, you know, why you, and not about the anatomy and physiology part, but about the speech science and the analysis of speech production. So you have, let's see, 6. Yeah, so you have 6 that you're responsible for. And so I would like you to post an original response and then respond to one other person's post. I will email you the rubric. Let me show you this as a student. Student mode. That I will use to grade, and that's in quotes, your discussions. Any questions so far? Okay, let's go back. Any questions about the assignments? Okay, so I'm going to try to make this all as painless as possible. So let's dive into acoustics, and some of it will be familiar to you because we, I wonder if it will let me do this. No, I'll just keep it out of, I'm going to go back and forth to presentation mode because I have some, there's animation in this, but I can't see the chat. I don't believe I can see your chat in animation mode. And when in presentation mode, let me see if it'll do that for me. Nope. Okay, so we'll keep it here. All right. So the study of acoustics is really basically physics, and although sound does not have a physical property, it's not a physical substance, it doesn't have weight, it doesn't have mass, it is a physical event in that there is an audible disturbance of air molecules through air, and air is the median, and that disturbance is created by some type of vibratory source. And so what you see there is just like a tuning fork set into vibration. The disturbances that are created are called waves. With regard to speech production, the vibratory source or the vibrating source are our vocal folds. For speech reception, the vibratory source is the tympanic membrane. And the simplest sound that has one frequency only is called a pure tone. Okay, now we don't speak in beats, so we don't speak in tones. We speak with multiple frequencies, and we're going to call those frequencies complex tones. So when a vibrating body disturbs the air molecules, it's going to vibrate forward and back, repeating itself the same way. And if that vibration is constantly moving back and forth in the same manner, it is said to be, we're going to characterize those waves as being cycles per second. So the number of cycles per second is the frequency. So the number of times that the vibratory body moves back and forth, disturbing the air molecules, creating waves, we call that back and forth oscillation the frequency of the vibrating body. And in order for something to vibrate, of course, it has to be elastic. So once that it is forced from its point of rest, that it is able to, sorry about that, guys, hold on. I found out that a childhood friend died today. It was really shocking. Okay, I'll cut that off. I can't deal with that right now. Okay. Any questions? I am too. It's just a shock. It just really is. Okay. So are we clear on, so a complex tone would be many cycles per second, which would be several frequencies per second that are produced when the vibrating body is vibrating back and forth. The opposite of that would be a pure tone. When the vibrating body is vibrating, it is only producing one frequency or one cycle per second. Okay, so this is a picture of a sine wave, and a sine wave is just a visual representation of sound waves. And so when a vibrating body moves forward, it pushes air molecules together here, and that's called a period of compression. And by the way, you guys, anything that is of a different color, font that has a line under it, it is a video that may help you. We won't listen to those tonight, but you might want to go back when you're studying and listen to those. So when the air molecules are pushed together, pressure is high, compressing the air molecules. When the vibrating body moves backward, pressure is low, and those air molecules are allowed to move and spread apart, and that's called rarefaction. So when there is one forward-moving, high-pressure period of compression, there is one backward movement, low-pressure period of rarefaction, and that is a cycle, one cycle. And so here we see one period of compression rarefaction, one period of compression rarefaction, compression rarefaction, compression rarefaction. So we have 4 series of that, therefore 4 cycles. And it's depicted on a sine wave. So if you can imagine a bucket with ink and a hole under it, and the bucket handle has a string attached to it. Along the floor, you have a piece of paper, and so you're going to set the bucket into vibration, moving back and forth, period of compression, period of rarefaction. The ink that falls on the floor along the paper will draw this back and forth movement, and that's a sine wave. So a sine wave is just a visual representation of what we really can't see with the air molecules moving together. And so this would be 4 hertz. This is still 4 hertz, but the amplitude is different, and we haven't gotten that far yet. We've got 1, 2, 3, 4, 5, 6, 7, 8 cycles here, and that would be 8 hertz. Question or questions? Okay. So when air molecules move apart and create low pressure, is it compression, rarefaction, refraction, or emittance? Okay, great, rarefaction. Let me see if I can also do this. Polling, poll type. Okay. So you may be able, I don't see them, but you may be able to see A, B, C, D next time. And you can correlate that with the number. Okay, let's go back. Now I'm going into presentation mode to show you the animation. So the pendulum, this would be the point of rest. And so it is set into vibration. It leaves that point of rest and moves to its maximum point of displacement. And if you can equate this or to a swing. And so when the swing moves forward, it has a millisecond where it stops before it returns and moves past the point of rest. So from the point of rest to the maximum point of displacement, you have maximum velocity. But at that millisecond where it stops before it returns, there is no velocity. The further the pendulum swings, or the higher the swing, the greater the amplitude. So the further the maximum point of displacement is, the greater the amplitude. The time that it takes for one cycle to complete itself is called its period. Questions? Okay, so the number of times that we have forward and backward movement is compression and rarefaction. One period of compression and rarefaction is a cycle. One cycle equates to one frequency. Now, amplitude is the distance that that oscillating body travels from its point of rest to its maximum point of displacement. That correlates to intensity. So when we're measuring it physically, we're going to refer to amplitude as intensity, cycles per second, yes ma'am, as frequency. So frequency, if we judge what the frequency of a sound would be, we would refer to it as its pitch. If we judge the intensity or the amplitude of a sound, we would judge its loudness. So the psychological correlate to amplitude is loudness. The correlation or the psychological correlation of frequency is pitch. Okay, so when you're measuring someone's fundamental frequency, and let's say the lowest usually fundamental frequency of a male is 80 hertz. So that's 80 cycles per second. Now, we're not, and you can measure that using instrumentation. When you're actually measuring the number of cycles per second, that's frequency. But if you hear that person speak, like in therapy, without using instrumentation, you're going to judge that person's fundamental frequency as a pitch because it's not a physical measure. Does that make sense? So let's say that you had a client that you felt as though their fundamental frequency was not normal. Okay, and you might say, boy, that person has a really high-pitched voice, or that person has a really low-pitched voice. The only time that you could use the word frequency would be if you physically measured it. You can do it with Pratt, you can do it with the CSL, you can do it with many apps on your telephone. So you can actually do that, and there should be a list of apps. You can actually do that in therapy and then compare it to normative data, and so you have an objective way to measure it. You can also determine if that person speaks at an average conversational level, which is about 50 to 60 decibel, which is intensity. And so we can actually measure the intensity of someone's voice in decibels. But in therapy without, or in a diagnostic session without instrumentation, we can only just describe the loudness of the person's speech. Questions so far? Let me get you back up there so I can see you. Okay, this is just another kind of depiction so you can see an image of how the sine wave is actually created with the oscillation of a pendulum. Now, if we were to look at a sine wave to determine its frequency, this is not the best one to look at. Let me see. Let's go back. We've done that. Let's go. We've talked about how to count the cycles, but in order to measure amplitude, if this is the point of rest, so I'm going to have to use, let's say, if this is the point of rest here, then this would be the amplitude here. So it's the point, the furthest point from rest, and that's at the point where there is minimum or no velocity, but just before it moves back. And so we measure amplitude by looking at the distance between the point of rest and its maximum point of displacement from here to here. Okay. So with this image, you see 3 sine waves. In one way, they're the same, and in one way, they're different. What's the same? Anybody take a stab? Frequency, right. So you have a period of compression. Stop, Valerie. A period of compression and a period of rarefaction. That's one cycle. Period of compression, period of rarefaction, 2. Period of compression, period of rarefaction. 3 cycles, 3 hertz. Now, each sine wave appears to have 3 hertz, but what is the difference that you see? The amplitude, great. So the distance from the point of rest is very different, and so we would assume that the first or the most superior wave has a lower intensity than the third one, and or a lower amplitude than the third one. Okay, so any questions about the difference between frequency and intensity? Okay. Okay. All right. So, with regard to reception of frequency or sound, a healthy ear can process vibrations as low as 20 hertz and as high as 20,000 hertz. Now, 20 hertz would have to have a pretty high intensity, or you would probably feel it first rather than hear it. But that's the frequency range of most humans. But the frequencies that are most important for the recognition and the production of speech rest between 100 hertz and 5,000 hertz, really from 500 to 4,000 hertz. So the frequencies of speech are contained within that range. But our vocal folds can only vibrate at its fundamental frequency. The normal range for a fundamental frequency is between 80 and really 400. 500 is just too high. 400 would be a screaming baby. So where do the other frequencies come from? Say, I'm sorry, Sophia, say what again? Okay. Does anyone know where the other frequencies come from? So we know that our vocal folds generate the sound, right, resonators. So our vocal folds can produce the fundamental frequency. Though that sound flows through our vocal tract, and there are 3 areas of resonation within our vocal tract that will add additional frequencies, because the frequencies within the range of the fundamental actually cause articulators or cavities to vibrate, producing other frequencies. But we'll get to that in a minute. This is just FYI. So humans can hear between 20 and 20,000 hertz, but a dolphin from 75 to 150,000 hertz. And dogs, so when your dog is howling or barking and you don't think that they're barking at anything, they may be. It's just because you can't hear it. It may be higher than 20,000 hertz. Okay, so are you guys comfortable with identifying frequency? And if I gave you numbers on the y-axis that you could identify amplitude. Okay, now, could you hear these? I know I have a little speaker there, and it actually makes sound, but it couldn't be 6 hertz, and it couldn't be 10 hertz because of what? What did we just talk about in terms of the frequency range of a human? We couldn't hear it, right? So we can't hear under 20 hertz. So really, it was just my way of kind of depicting to undergraduate students the difference between a low frequency sound and a high frequency sound, and trying to give them a sine wave that had 80 hertz on it. 80 cycles wouldn't necessarily work. So that's the fallacy with that. Okay. Oops. Let's move on. Okay, so how many hertz are here? What is the frequency of this sine wave? Five. Great. Okay. Any questions? Okay. The unit of measure for intensity is decibel. Correct. Which is true. Wait. We've not talked about that. I must have skipped. I did. Okay. This is really important. Sorry I skipped it. And please look at these videos because this explains vocal registers. Okay, so we know what a hertz is, and we know the period is just the time that it takes for a cycle to complete itself. But what if there were actual changes in the vibrating body itself? So what would happen if we lengthen a pendulum and set it into vibration? Would it oscillate at greater cycles per second, or would it oscillate at less cycles per second? Think about, go back to if you guys ever like to swing. Well, you guys are maybe too young to remember when you could actually make the swing shorter. Right, so the longer the vibrating body, the less cycles per second. We could also equate that or use a musical instrument as an analogy. An upright bass has longer chords. When it is set into vibration, produces a lower frequency sound. A violin has shorter chords. When they are set into vibration, they will produce a higher frequency sound. So, as the length of the oscillating body increases, the frequency decreases. So it's inverse. It has an inverse relationship. So when a person elongates, no, I'm not going to go there because it really has to do with mass. What about mass? So you've got two swings. You've got an adult on the swing and a child on another swing. The same amount of force is pressed. Who will swing with more cycles per second? The adult with more mass or the child with less mass? Okay, the child. So we have another inverse relationship. The greater the mass, the less cycles per second. So that is why a male has a lower fundamental frequency normally than a female. A male has greater mass within their vocal folds. They're longer, and they have more mass. And so therefore, their vocal folds vibrate at a lower fundamental frequency than a female, or better yet, than a child that will have a shorter, thinner, less mass set of vocal folds, and so their fundamental frequencies would be higher. And really, when you start looking at the effects of frequency, particularly when it comes to registers, so it really has to do with mass. So if you want to speak in a higher register, then you are shortening your vocal folds to vibrate at a higher cycle per second. Now, what about stiffness? Think about a guitar. When you tighten the cords, you're desiring a higher frequency note or a lower frequency, higher. So this is the only one that has a direct relationship. The greater the stiffness, the higher the frequency. So when our vocal folds are stiffer, they vibrate at a higher frequency. Let's say that you are a female, your fundamental frequency is about 230, but you acquire vocal nodules. You have now acquired more mass. What will happen to the fundamental frequency for that person? It will lower. It will be abnormal. Okay? So that's the physics behind that. Questions about the effects of length, mass, and stiffness on frequency? Okay. Keep going. Okay, so which is true? As the vibrating source lengthens, the frequency decreases, or as the vibrating source, that's bizarre. As the vibrating source increases in mass, the frequency decreases, or as the vibrating body becomes more stiff, the frequency decreases. Which one is true? Are you sure? Okay. Let's look at let 3, Kelly. So if we have a guitar and we make the chord stiffer, then the frequency, yeah, there you go. Okay, great. So we've talked about the psychological correlate of intensity being loudness, and you can actually measure it, but it is measured based on a subjective judgment. It's a scale. You can't physically measure it. We can physically measure intensity, but not loudness. And the unit of measure for pitch is phone. But it's based on that person's judgment. The psychological correlate of pitch is frequency, and its unit of measure is male. And you'll probably never use that. So this is a picture of the CSL. I actually have it in the audiology clinic now, and that's what you're going to use. It also has software for the VisiPitch. And so the CSL and the VisiPitch. Now, the neat thing, although we don't have the software, is that you can use this in therapy and provide reinforcement. So let's say this young man, you are working on, let's see, let's say you were working on him, and let's say that he's severely to profoundly hearing impaired, because most individuals that have vowel errors are typically hearing impaired. And let's say that you want him to correctly produce the ah. And so when he speaks into the microphone will analyze the ah, will determine if the first, second, and third format is within normal limits. And if it is correct, then the frog will hop to a different lily pad, giving him positive reinforcement. And so that's just a way of using instrumentation, not only to physically measure whether he produced it correctly, as opposed to relying on you watching the placement of his articulators. You can actually measure or analyze the frequency characteristics of his production, and then determine what he's doing incorrectly by looking at which format is possibly produced at a different frequency, but we'll talk about that in a minute. So I'm sure that there are more up-to-date actually apps that you can probably find to do that. Okay, so a while back we talked about complex tones, and the only time that you ever deal with pure tones is when you're screening someone's hearing. But with regard to speech, when our vocal folds vibrate, and we've already determined that when that phonation flows through the vocal tract, additional frequencies are added. So when we speech is complex, is made up of complex tones. Those complex tones are either periodic or aperiodic. Periodic means that the vibratory source is oscillating the same way repetitively. All of the frequencies that are vibrating as a part of that complex tone production, you can see a pattern in the oscillations of the frequency. So here you see 3 different sine waves. All look a little different in frequency, and one looks a little different in amplitude. But there's a repetitiveness about each vibrating or each sine wave. When our vocal folds vibrate, they vibrate in a pattern, and they produce a periodic sound. Now, when an aperiodic sound is producing noise, so if you notice for a periodic sine wave, there's no set frequency, there's no repetitiveness about the oscillations or the intensity, and so that's aperiodic. Periodic sounds, or your vocal folds, produce periodic sounds, and therefore they're responsible for the production of vowels and voiced consonants. So anytime your vocal folds vibrate normally, they are producing a periodic sound. Now, if there's some type of disorder, edema, a mass, then they may not vibrate repetitively. But normal vocal folds should have a repetitiveness and produce a periodic sound. And so when we produce a vowel, that periodic sound produced by our vocal folds flow through our vocal tract unobstructed. Now, if we were to open our vocal folds, abduct our vocal folds, and just produce the sound, we're just letting air come through, and that's an aperiodic sound. There's no repetitiveness. A voiceless consonant is entirely aperiodic because what we're doing is producing noise. So let's say a voiceless fricative, the sound. Our vocal folds are not vibrating, so there's no periodic component to it. And air is being blocked, or friction is created by blocking the flow of air. And so we're just producing noise. So voiceless consonants are aperiodic. Voiced consonants are periodic and aperiodic because our vocal folds are vibrating and we're obstructing noise, or we're causing a stop release. Or with vowels, we're just producing a periodic sound. Does that make sense? Okay, now, I'm not going to go into phase, you guys. Let's not worry about phase. Okay. So when your vocal folds vibrate, phase is really not used in speech production. It's used with acoustics. And so we're just going to kind of leave that there for right now. So the lowest frequency of a periodic wave is its fundamental frequency. So the lowest frequency of your vocal folds vibrating is its fundamental frequency. However, your vocal folds, when they vibrate, they actually vibrate in a ripple, in that there are kind of multiple vibrations happening. And so the lowest frequency is your fundamental frequency, but your vocal folds also produce a multiple tone or frequency of the fundamental frequency, and it's called an harmonic. The harmonic, so if your fundamental frequency is 80, then the second harmonic is 2 times 80. The third harmonic is 3 times 80. The fourth harmonic is 4 times 80. And so when we're looking at a periodic production of your vocal folds, it not only produces the fundamental frequency, but it produces harmonics, generally up to about 8,000 hertz. Let's see, watch, and I know you guys have seen vocal fold vibrating, but watch the multiple areas that are vibrating. And so that's how you're actually producing multiple frequencies. So it's not as though they're just hitting each other solid and producing one sound. Sorry about that. Okay. The same with a guitar string. So if we wanted to look at the fundamental frequency, which we would call the first harmonic, and we plucked it, we would only have one string moving and vibrating repetitively. Now, if we apply pressure in the middle of that string, creating 2 separate vibrations, but a multiple of the first, that would be the second harmonic. So the rippling effect that you saw this would be the same analogy. And so for the third harmonic to be produced, there would be 3 areas that are vibrating in multiples of the first. So the first is your fundamental frequency, or the first harmonic. The second one would be 2 times the first, 3 times the first, 4 times the first, and etc. Questions? Okay, so if we were to see that on a sine wave, the green is represented by the first harmonic. That's 1 frequency. The red is represented by the second harmonic. The blue is represented by the third. There are 2 types of ways to depict sound for analysis. They're called spectrograms. This is called a line spectrogram. Each line represents a cycle. Each line represents a frequency. Well, not one cycle, but represents a frequency. And so the first line is the fundamental frequency. And if you notice, it's the lowest one, right? This is 500. This is 1,000. So the lowest is the fundamental frequency, or the first harmonic. It always has the highest intensity, or the highest amplitude. The second harmonic is double the first, but if you notice, it is slightly reduced in amplitude. Usually each harmonic decreases in amplitude by 12 dB. So between the first harmonic, and don't know how many are there, let's say 30 harmonics, we're up to about 3,500 hertz, but the intensity is lower. This is a depiction of the complex tone produced by your vocal folds, the fundamental frequencies, and each harmonic. And so, well, let me correct myself. The first line is your fundamental frequency. The harmonics that are produced are also as a result of going through your vocal tract and okay, hold on. Your vocal folds produce the fundamental frequencies and harmonics of those frequencies. That is called the source spectrum. The source spectrum flows through your vocal tract, and the spectrum is then filtered or modified by resonators. So this is your source spectrum. And resonators are resonating bodies respond. Okay. You guys, I'm going to stop because I see that I'm doofy tired because I can't even explain it. Let me show you one thing and then I'm going to stop because I'm getting doofy. I need to upload this into your course. Okay. When a body is set into vibration, whether it's vocal folds or cavities within your vocal tract or a flute or a saxophone, there are certain bodies that can be set into vibration that vibrate best to a certain frequency. So there's a tendency for one vibrating body to set another vibrating body into vibration. And that is called resonance. And let me see if I can. And there are certain, it could only force another object into vibration if it matches its resonant frequency. So, well, let me put it this way. The second body can be set into vibration more easily if the resonant frequency matches the frequency of the initial vibrating body. Let me show you this and then I'm going to stop. Now I want you to watch how this works. So if you notice, only the other red one began to vibrate when we're setting the initial one into vibration. So because of resonation only, and because that it's only the green, each color matches the resonating frequency of the originating body. So when you set the red one into vibration, only the second red one vibrated because its resonant frequency matched the frequency of the object that set it into vibration. And I'll go over this again. So if this is what's produced by the vocal folds, that's not good. That's our source peak frequency. That's our source spectrum with the fundamental frequency and the harmonics. As it flows through the vocal tract, depending on the position of our articulators, will depend on which of the frequencies, which of the resonant frequencies match the frequency of the spectrum. Those that match will increase in amplitude, and that's where you see the peaks. So this is the original source. This is the formants that represent how your articulators are placed, and this is what actually is produced. And so the change between the original source and what the output is, or what the production is based on how those harmonics were altered due to resonance. Okay, let me put that back. Okay, folks. Traveling, yes it does, and I'm getting you dizzy. Okay, and then this is kind of wacky. Okay, so what we're going to do for next Tuesday, I'm going to quickly review the first couple, the up until resonance for sure, and then start on resonance. And if you could look at that resonance PowerPoint, I think I actually have something else that I'm going to upload. I'll upload that for you to look at and start looking at and studying formants. And I think we talked, didn't we do this in audiology? Did we talk about formants in audiology when we talked about acoustics? Oh, did we? I don't know. Do you remember talking about formants in phonetics when you took phonetics? Okay. So we're going to go back over that, and we'll talk about which positions of or which articulators are responsible for altering the cavity that produces a certain formant or a certain resonance frequency. Are there any questions about, and so for those of you that came in late, we're going to meet next week. We're going to review and finish this chapter out. I'll open up the test immediately following through the weekend. We'll cover respiration and neurology. That test will be also that weekend. And then we're not meeting again to the 27th, and we will review 3 chapters: acoustics of vowels, articulation of vowels, articulation of consonants, and prosody. Then we'll meet. I'm shooting for the 3rd week in July, and we will. Let's just do the whole table of contents. We will then do feedback mechanisms and audition. So if you weren't here before, the problem is this class really should be the anatomy class that you had the 1st semester or the 2nd semester, because it involves anatomy and physiology and speech science. And since you guys have already had that, I'm not going to spend a lot of time on anatomy and physiology. We're just going to stick with speech science and speech perception. So we have, and that cuts down on quite a bit of the class time. Okay, I'm glad you heard the term, but I know you guys are busy. I'm not sure how many of you are already placed. But if you could take some time and look at the information, take some time to look at we're going to have to cover phonation too. Yeah. Take some time and look at formants handout. And I need to make sure that's the latest one. Before next week, that will be great. And we might just hit phonation, at least start on it. That might make more sense. Are there any questions? Because it's the same thing as what we're talking about now with formants. Are there any questions? So next week, we'll go back to our regular time. Is that okay at 5:30 Central Standard Time? Okay. And we'll try to knock out those chapters and then meet again probably the last week in June. But I'll send you an updated outline and revise your due dates on your Dropbox and the assessment for this weekend. And we are going to try to knock out that Lab 1 immediately following the completion of the subjective portions of your comps for those of you that are taking it. For those of you that are not, if you would email me and let me know that, then we'll come up with something to substitute for that. Okay. Thank you for being patient with me. And you guys have a good rest of the week. And I'll see you next week. Thank you. Appreciate it.